Welcome to ClickMyProject.com. Let me discuss about the process particle swarm optimization based hyperspectral dimensionality reduction for urban land cover classification. Let me discuss about the abstract of the project. Hyperspectral images show similar statistical properties to natural grayscale or color photographic images. However, the classification of hyperspectral images is more challenging because of the very high dimensionality of the pixels and the small number of labeled examples typically available for these peculiarities lead to particular signal processing problems, mainly characterized by indetermination and complex manifolds. There are several algorithms has been proposed to classify the hyperspectral image. In our project, a new novel method has been introduced, that is principal component analysis based classification, such as PCA, PSO, SVM approach. This new approach accurately classifies the cluster head with respect to their amplitude and phase. Principal component analysis is introduced to extract the feature from hyperspectral images. Amplitude and phase features has been obtained by derived PCA. Then select best feature among extracted features by particle swarm optimization. Finally, classify the respective band with related cluster, which is performed with the help of support vector machine. This classifier accurately classifies the band to respective cluster form. In future work, this process will carried out by interacting PCA, BFO or VM. This combination leads to provide good accuracy and also limited computational time because of using BFO, that is Bacterial Foregoing Optimization algorithm, can obtain less computational time compared with our proposed approach. Let me discuss about the flow diagram for our process. Initially, hyperspectral image has been taken as a input image. Next, if the hyperspectral image having more than 3 bands, then that is a hyperspectral image. If not, then there is a normal image. Next, PCA analysis. So in the input pre-processing step, input image need to read from database, the input image and filtering part to process the MATLAB domain because of the process are mainly focused by image processing technique. Next, in the principal component analysis, that is PCA. PCA is the simplest of the true eigenvector based multivariate analysis. Often its operation can be thought as of a revealing the internal structure of the data in a way that best explains the variance in the data. If a multivariate dataset is visualized as a set of coordination in a high dimensional data space, PCA can supply the user with a lower dimensional picture, a projection or shadow of this object when viewed from its most informative viewpoint. Next, using the PCI, we can reduce the hyperspectral image dimensionality. After dimensionality reduction, we extracted the remaining features. Then the selection process carried out using PSO, that is particle swarm optimization. PSO shares many similarities with the evolutionary computation techniques such as genetic algorithm. The system is initialized with the populations of random solutions and searches for optima by updating generation. However, unlike has no evaluation operators such as crossover and mutation, in PSO the potential solution called particles fly through the problem space by following the current optimum particles. Finally, the selection features are classified with the help of SVM classifier, that is support vector machines. Support vector machines are supervised learning models with associated learning algorithms that analyze data and recognize patterns used for classification and regression analysis. Given a set of training examples, each marked as belonging to one of the two categories. A SVM training algorithm builds a model that assigns new examples into one category or the other, making it a non-probabilistic binary linear classifier. Let me discuss about the running procedure for our process. Select the main.m file in the current folder, and run for executing this process. Here we have to select dataset from the dataset folder. Here Salinas images are taken as a hyperspectral images. So the Salinas images are selecting. This is the best band using PSO algorithm. And after that, SVM classifier are classified for each resultant best bands, and the cluster results are displayed in the main one window. Each color represents some classes that are displayed here. After once the entire bands are selected, the performance has been analyzed. Here this is the figure 1 window for the first band, 152 band, and this is the 187th band cluster result. This is the 128 band cluster result, and this is the 7th band cluster result. This is the 164th band result, and this is the 183 band result. This is the 132 band cluster result. This is the 146th band cluster result. And this is the 153 band cluster result. This is the accuracy result for our existing and our proposed system, and this is the bar graph for existing and proposed system. Thank you.